All right, we're going to look really quickly at elementary reactions in general. All right, I'm going to start with the whole concept of how we go about determining the rate order and how we get elementary reactions. All right, so I'm going to look at one of the examples we did in our class, which was a substitution reaction where we took a alkyl halide. This one's our groups with carbons and hydrogens and then a chlorine in it. And then we reacted it with water. And our overall product was that same thing on the left there with that carbon, but now attached to an OH. And the chlorine would be over here with an HCl. Now, having just those two reactants, we know for sure the rate law would involve them both, potentially, and only those two things. But since the rate law has to be experimentally determined, we'd write this with an M and a N to say we have no idea what they actually are. So if I give you just a random equation, we don't know anything about it with regard to the rate law. It has to be experimentally determined. All right. If we actually go through the whole process and determine the rate, we actually do find out the rate of this particular reaction looks more like just this. Do the first, and the water is a 0th order. It's generally even left off, so the rate law ends up mostly just looking like that. All right. We can use the rate law to determine the mechanism for which this reaction goes, and it looks something like this. Now, the purpose of this video is not to show you how we came up with this, just to actually introduce the concept of elementary reactions. But what's going to happen at first is that chlorine's just going to rip off, take those electrons with it, become negative, and then that cation bumps into the water, and we make another cation, and then that bumps into that chlorine from that first step. Guess I've dropped my positive. And we get a CH3, 3COH. I've been dropping my C there. Let me fix that. This carbon is still here, and the OH2 was attached to it. And here we've lost the H+, so it's now just an OH, and it is now with that chlorine. Make that prettier. All right, so this mechanism is what we actually see in this overall process. This is just the individual steps. So it's a 3-step process, 1, 2, and 3, where this is actually the slowest step, which generates the rate law. That's why it only has the single reactant in there. All right, once I know a mechanism, I can call these individual steps elementary steps. The 3 elementary steps do indeed add up to give us the overall process, but this is how the reaction actually occurs. So if I am able to label these as elementary steps, I can generate the rate laws right from the equations. And it is just looking at the reactants. And putting them to the power whatever coefficients there are. Now this one actually has 2 things in it because there's 2 reactants. And so does this one. But the coefficients will always match the powers here. So since every single one of these implied to have a 1 in front of it, these are all first order with respect to their species. But the only one that's really important to the overall reaction is that slow step. So only that rate law is able to be seen. The rest are happening so fast that we have no ability to control anything on them. Now also, since we labeled these as the elementary steps, we can look at the number of reactants and come up with their terminology. This one, for instance, is unimolecular. The second one and the third one are both bimolecular. They have two reactants, it's bimolecular. So as long as you see the elementary part, you can actually just call out what the order is. So for instance, if I just have a reaction, a very general one, where I just do the numbers, if I just say 2A and we'll say it goes to B, what it goes to doesn't matter. When we do the rate law, it's always dependent on just the reactants anyway. So the products don't necessarily matter when we determine the rate law. But if I do not call that elementary, the only thing you can say for sure is the rate law has something to do with A, but the best we could guess is it's just to some random order. It's probably first, second, or zeroth order, but we don't know. That has to be experimentally determined. But if I give you the exact same equation, and after it I put that it's elementary, then the rate law matches those coefficients. And this is second order and bimolecular. So you're just looking for that word to make the call on it.